Okay, for the intro to forces, this is now the next part. We talk about net force. So what is net force? Now, it's the interaction of forces. When you have more than one force acting on an object at the same time, simultaneously means at the same time. Okay, let me get my marker here. Simultaneously, it means at the same time. The net force is the vector sum of all the forces, which means that you're adding up your forces. Okay, adding up forces, we talk about net force over here. So another name for net force, we call it the resultant force, or we call it the unbalanced force. As you can see, because this is yellow, which is this a more important name, you must know resultant force. So when the forces interact, okay, they tend to cancel each other out, or they add on to each other. We call it the resultant force, and we will call it the vector sum. Okay, we will cover this more in upper sec, but just take note, we call it the vector sum. Okay, so resultant force is a thing that we're going to learn now. So in terms of net force or resultant force, so when we have two forces acting in the same direction, 3 Newton here, 5 Newton here, we can add them up because they are in the same direction. So what is the resultant force in this case? So as we have scribbled here, we take the 5 Newton adding to the 3 Newton. So what's the resultant force? Take note, whenever you calculate resultant force, there's always two parts. Okay, two parts. First one is the size of the force. Okay, size of the force. So you can see here 8 Newton. This is part 1. The second part is what we term as the direction. So you can see here to the right. This is part 2. So the two parts that we need to see is the size and the direction of the force, of the resultant force in this case. So this is with regards to the calculation. And you can see in terms of the drawing, when it's a force, we use an arrow. Of course, the bigger the force, the longer the arrow. The resultant force is normally indicated by the length of the arrow and the length of the line and a double arrow. So double arrow indicates resultant force. Okay, so you can see here 3 Newton plus 5 Newton. You got a longer arrow here, which is 8 Newton. In which direction? It is towards the right. So parallel forces in the same direction. Now, what if they are in opposite direction? So you can see here, let me put this one side. Okay, you can see here the opposite direction. So how to do the calculation? Once again, we add up the forces. But because 3 Newton is in the opposite direction, so we put a negative sign over here. So resultant force is 5 Newton plus opposite direction, so negative 3. In the end, it is 2 Newton, which is part 1. We talk about the size of the force. To the right, we talk about the direction. So resultant force always consists of two parts. 1, the size. 2, the direction. So you can see here, when I draw it out, it will be a line towards the right with double arrow because it's the resultant force. Okay, double arrow just tells you that it's the resultant force. Okay, so don't think that it's too complicated. Just know that resultant force, double arrow, and it's supposedly shorter. Okay, so take note, you draw longer forces for longer. Draw longer lines. Okay, not longer forces. Longer lines for larger forces. Okay, longer lines for larger forces. And the last case here, we know that, okay, since there's in the same direction, opposing, and what if it is adding up to 0? So 3 Newton, resultant force 0 Newton. So 3 Newton plus opposite direction, so it's a negative 3, overall is 0. This object here with no resultant force, we say that it is in a state of equilibrium. Okay, state of equilibrium. What will happen to the object? It will either remain stationary, okay, so when the resultant force is 0, the object will just stay there, or it will continue moving in a straight line. Okay, so for example, if my box is moving in this direction at 3 meters per second, okay, I add a force in front and add a force backwards, the resultant force is 0. It will continue to move at 3 meters per second. Okay, maybe 4. Okay, maybe I use 4. 4 is a better way of saying it. I use 4 meters per second. So if I move, so it's moving 4 meters per second. I add a force 3 Newton forward. I add a force 3 Newton back at the same time. Okay, 3 Newton at the same moment. My block will just continue at 4 meters per second because the resultant force is 0. So that's what it means by continue moving in a straight line. Okay, adding on at a constant speed. Okay, at a constant speed. So this is the end for the net force. We talked about type of forces, we ended up in net force. So this marks the end of the first whole part of forces.